Welcome to lesson 2125, multiply and divide radical expressions. I could have stuck this in a long time ago, but I wanted to go over polynomials and exponents before I stuck this in at the beginning of algebra, early in the 2000s, where I go over multiplying and dividing expressions. So this is stuck in with polynomials. So here's our objectives, our vocabularies, some products of square roots. So remember, if you have this funny looking thing is your radical symbol, your square root. And if there's no number sitting here, you know it's to the second power. So the square root of A times the square root of B is the square root of A times B. It's the same thing. So they put numbers in here to show you, and we are going to factor and combine to simplify expressions. Okay, so some rules and notes for you. So this root is always supposed to go all the way over the square root of A. See, all of that is supposed to be under the square root symbol, but I can't type that up on the computer. Here are some notes for you to read through to remember your parts of a root. And so let's simplify -2 times the square root of 108. So we're going to separate 9 times 12. And what you're looking for is square roots. So let's see, 12 times 9 is 108. And then 12 can break down into 4 and 3. If I do -2 times the square root of 9 times the square root of 4 times the square root of 3, -2 times 3, because the square root of 9 is 3, the square root of 4 is 2, times the root of 3 becomes 4 times 3 is 12, -12 root 3. 108 is also 36 times 3, huh? Yep, 108 is also 36 times 3. So, same thing. Okay, the square root of 147 x squared times y. And what you need to do is find perfect squares. So remember, our perfect squares are numbers like 1, 4, 9, 16, 25, ... 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. If you need a refresher on your squares, please go back and look in numbers and operations where I went over square roots. So we're looking for, let's divide this by 9. 1 and 147, 157. 6 goes 54, but we have a remainder of 3. So you have to break 147 down into, let's see, 49. 49 is 18. 98 and 47 makes 5. 145, that doesn't get me to 147. So you have to take your 147 and divide it by perfect squares. Because this ends in 7, it's not divisible by 5. It's not divisible by 25. 36. What's after 36? 7, 49. Oh, wait, I was supposed to add 49. Why did I add 47? Brain for art. Oh, look at that. 49 times 3. So this breaks down into the square root of 49 times the square root of 3 times the square root of x squared times the square root of y. 49 comes out of 7, x comes out, and then you're left with 3y under the radicand. And I'm using those principles that I showed you from the earlier slides, from the picture slides. Anything squared, if you have a number or a letter squared and you take the root of it, you just get the letter out. This square root cancels the power out. And that's why you need perfect squares, factors of perfect squares. Okay, 3 times the square root of 63 p to the 5th q to the 6th r. So 63 is 9 times 7. So let's break this down into factors. The square root of 9 times the square root of 7 times the square root of p to the 5th times the square root of q to the 6th times the square root of r. And so we need to break down p to the 5th as p to the 4th times p times q to the 6th times r. So it's root of 7, root of 9, and then 3. And what comes out? 3 comes out here. The square root of 9 is 3. The root of 7 stays. P to the 4th, you divide 4 by 2, you get 2. So p squared comes out. Then you have root p. 6 divided by 2 is 3. So you have q cubed and the square root of r. And let's combine everything outside the roots. So 9 p squared q cubed root 7 p q r. And this is how we simplify radical expressions. Okay, so those were our 3 examples. So please work on the practice problems, and I will see you at the end of the video. Okay, all of this is under the radical symbol. I just can't get that to come out on the computer. All of this is under the radical symbol. And all of this is under the radical symbol. So try these practice problems, and then I'll see you at the end of the video. Okay, so this square root is supposed to go over them all. Okay, so 4a comes out, b squared comes out, and C cubed comes out, and what stays under? 1b stays under. Why? Because you did b to the fourth times b. And you can see that if you divide 4 by 2, you get 2. So that is simplified. The only thing that comes out is the y and times the square root of 5x. $189. Let's see what 189. We start dividing by the lowest perfect square that we know of, 9. 21. 21, its multiples are 7 and 3, which are not perfect. Okay, so we got 9 times 21, m to the fourth, m, n squared, n, all under the radical symbol. The square root of 9 is 3. The square root of m to the fourth is m squared, n, taking off that first one. And what stays under the radical sign is 21 mn. And that's the answer. Okay, and 162. So a fourth is going to come out, a squared is going to come out, 9a squared times 162b, 162. Let's see, is it divisible by 4? 162, is it divisible by 4? 4, 16, 2, not evenly. Okay, so that doesn't work. 1, 4, 9. Let's do 9 just for S and G's. Let's see, 162 divided by 9. 1, 9, 16 is 72, 18. So 18 breaks down into 9 and 2. So 9 times 9 times 2 is 81 times 2. Okay, so is the square root of 81 times 2 times b. And the square root of 81 is 9. So minus 81, a squared outside, 2b stays inside. And there you go. That is how you simplify radical expressions. Thanks for watching this video. If you made mistakes, don't worry about it. Just keep on practicing. You'll get it. And keep on watching the video. Sometimes you have to watch it a couple times and practice and make mistakes. And that is the best way to learn. So thanks for watching. And I hope to catch you on the next video. This was not directly related to polynomials, but I put it in here because I thought it fits best here. So please go back and watch in numbers and operations dealing with exponent laws if I went a little too fast or you didn't get it. Okay? And I talk about taking roots of numbers. And thank you again.